All right, so for those of you that forgot to tune in, Nathan forgot to remind me to record, so I'm doing that right now. Just kidding, Nathan reminded me to record, so pause on this to record this. You haven't missed anything else. And now it's the next page, which is whoosh. Thanks, Nathan. All right, give me a thumbs up when you're done this page. Well, it could have been worse, not the end of the world. I still hate it when I do stuff like that. Can't wait till I get old enough to stop making mistakes. That's gonna be amazing. Thank you, Kate. Kate was not messing around this time. Thank you, Nathan. Thank you, Matthew. Thank you, success. Oops, just broke my camera. That's awesome. Fix that after. All right. So these are important little bits of information, but obviously this is going to be where the majority of the work will be. And it's honestly, it's nothing crazy. It's just making sure you are comfortable with formulas and solving for an unknown. Again, this is important stuff, but this is where the rubber hits the road. I'll do some examples with you, but the assignment is page 391, 1 to 7. Let you copy that down while I find the pages I want to go over. 391. All right. Okay, so there's a couple tutorials in this one section. So first one's page 389, practice questions. I think they're all relatively straightforward, especially considering some of the stuff that we've had to do. So this one here says if a wave has a frequency of 230, frequency equals 230 hertz, and a wavelength of 2.3 meters, wavelength equals 2.3 meters, what's the wave speed? Well, the equation is wave speed equals frequency times wavelength. So we're just plugging numbers in. 230 times 2.3. $529. We need 2 sig figs, so that's 530. Speed, meters per second, not velocity, speed. And that's kind of as hard as it gets for determining wave speed on its own. So I'm not gonna do the other two questions. Once we get to the end, if somebody really wants me to, I will. But they're just like that. But the next section is a little bit trickier. Not a whole lot. Page 391, numero uno, says if a 2.5 meter long string, so the length equals 2.5. I realize I'm going to run out of space here. Length 2.5. On a wave machine has a tension of 240 newtons. So FT, F sub T is tension force, so that's 240 newtons. And then the wave speed is 300 meters per second. V equals 300. What's the mass of the string? Okay, so we have two formulas we're working with here. V equals F lambda. And then we also got, what's the other one? V equals the root of Ft over mu, or linear density. So, oh, we got one more, sorry. Mu equals mass over length. Okay, so length, we can see we have kind of length and we need mass. So we need mu. That's not in here at all. So we're going to need mu to be able to use this formula. The only other formula is this. We need speed and force. Speed and force. We have those. So we're going to start with this, solve for this, then use it to go over here. Cool, cool, cool. So using this one first, V equals the root of Ft over mu. Speed is 300. Tension force 240 over, oh yeah, we don't have it, mu. So we're going to square both sides. I don't need the calculator for that. We're going to square both sides. So 300 squared would be 90,000. 9 and 4 zeros. And then the root sign just drops, 240 over mu. Shortcut to this, you multiply both sides by mu, and then divide both sides by 90,000, or just switch them. So mu equals 240 over 90,000. .0026 repeating. So that's our mu. I'm going to go back up to do the other formula, but this is our mu. So now we're going to use this formula. Mu equals m over L. Mu is 0.0026. And the nice thing is if you leave that in the calculator, you don't have to retype it out. You can just use that to be part of your next question. Equals m, we don't have m, over L, which is 2.5. Multiply both sides by 2.5, so we're multiplying this by 2.5, and that's going to give us our m. M equals, so the mass, this times 2.5, 0.0067, and I'm rounding it there because we need 2 sig figs. Is that right? So let me make sure. No, it's 1 sig fig because it gave us the 300 meters per second. So it's going to be 0.007, or, and that'll be in kilograms, or 7 times 10 to the 1, 2, 3 to the negative 3 kilograms. Textbook is wrong because of sig figs. Should have 2 sig figs. That's about as hard as it gets, my friends. Any questions? If you're putting up a hand or something, I can't see it. Let me just see. Any questions? It gets easier from there. These 2 examples, they're not asking you to kind of float around between formulas or anything. Anything else you want me to go over? Otherwise,
mu can be like a coefficient of friction, and it can also be the linear density.
Unfortunately,
okay.
The only thing is with when it's coefficient of friction, it'll either be like mu K or mu S or something like that. In this case, it's just mu.
Oh, okay. So it's easy to tell them apart.
Yes, yeah. And I don't know where in my years of teaching this, like we've never kind of had the overlap here. Some things overlap, these ones don't. When we're talking about like sound waves and friction, we're not going to cross those paths. Anybody else? Then that's all I got for yous. Have a lovely day. See you tomorrow. You can always message me if you have questions or anything.